All right, y'all, let's do this. We have parabolas today. And just like circles on the last one, we are going to be given the general form of a parabola, and we must complete the square to put it into its standard form. So we will be completing the square to create a parabola. But that is just going to be on one example. So let's actually go over the pieces of a parabola, what a parabola is, and go from there. So first up, the confusing definition of a parabola. A parabola is a collection of all points P in the plane that are the same distance from a fixed point F, the focus, as they are from a fixed line D, the directrix. Now, if you were into extreme geometry, then maybe that would make sense. We are not. We are in trigonometry, so we just want to just touch on the components of parabolas and how to find the equations of parabolas. Thank goodness, right? All right. So what you see here is parabolas are going to have a main point. Parabolas are going to have something called the vertex. That is the vertex, what I circled there. And the way to determine how a parabola opens is the placement of the focus. Oops. Is the placement of the focus. So if the focus is above the vertex, the parabola will open. If a focus is below the vertex, the parabola will open down. To the right of the vertex, opens right. To the left of the vertex, opens left. So you can get a lot of information if you just have the vertex and the focus. Okay. Another component is something called the directrix. What is the directrix purpose in life? Nothing. It is just a fixed line to help you find the distance from the vertex to the focus and help you find that special value of A. A represents the distance, so listen closely. A represents the distance from vertex to focus, and A also represents the distance from vertex to directrix. So A is very important here. A represents that distance. And if we know A, that is an important piece of information that we need. Okay, and then another component is the line that cuts straight through the parabola, right through the focus, right through the vertex, and that is called the axis of symmetry. Sometimes the axis of symmetry is your best friend. So let's say we have this point P over here and we have nothing else. Well, we know that we could reflect this point P across it and get the same point P over here for being symmetric. Awesome, right? Okay, now I scribbled all over this. Great. Okay, so just like I said below, the axis of symmetry, it's a line that cuts through the focus and is perpendicular to the directrix. The vertex is the midpoint of the parabola, or it's the midpoint of the segment between the focus and directrix, or the point of intersection of the parabola with the axis of symmetry. A, which is very important to us, A is the distance from vertex to focus, or directrix to vertex. The distance, A, is always positive. Oh, the last funny one, the lattice rectum. It is the line segment that joins the 2 points, depending how the parabola opens, x and k plus or minus 2a, or h plus or minus 2a and y. It is the points above and below the focus, or again, depending how the parabola opens, it can be the points above or below, or it could be the points to the right and to the left of the focus. All right. And the length is always going to be given by 4a. All right, so let's just go back up. Let's see. So if I were to draw it on here, and since this parabola opens up, the lattice rectum would be the point to the right. One point would be to the right of the focus. And one point would be to the left of the focus. That would be the lattice rectum. Okay, and now it kind of looks like a contact. So maybe this is how we do depth perception and all that fun stuff. But again, maybe that's for another lesson. Today is let's get all the algebra, all the components, and make equations of parabolas. And yeah, there is one application at the end. All right. Excellent. Maybe I can draw that on here. Hang on. Let me back up a bit. Let's do it. I'll say here. And there. Yes. This is the lattice. Eyeball, contact, whichever, right? All right. That's the lattice rectum. Okay. Now, the next page is strictly formulas, letting us know how the parabolas open. All right, so, and what equations to use for the way the parabola opens. So let's look at the first picture. This guy right here. If your parabola opens to the right, then your vertex is known as HK. Your focus is known as H plus the value of A, comma K. Your directrix is known as H minus the value of A. Your lattice rectum, since it opens to the right, your lattice rectum will now be a point above the focus and a point below the focus. That's why it says y plus or minus 2a, because I put it as whatever the y value of your focus is, you're going to go up 2a and you're going to go down 2a. These formulas look really complicated, but trust me, it's actually really simple, okay? Because look at how I put these points. H plus or minus A and K plus or minus 2A. When we get there, it's easier. So all we really have to focus on is what equation to use. Since this parabola opens to the right, we will use the first equation. And that's all we really need to know. All right, let me erase all of that. If the parabola opens to the left, we use that equation, the second one. And notice the big difference between both equations. If you open to the right, 4a is positive. If you open to the left, that 4a is negative. Now that doesn't mean a is negative, it just means that that 4a is negative. Because remember, a is always positive. All right, excellent. So that is if your parabola is open right or left. And we will compare a slight difference between parabolas that open right and left and up and down in 1 second. Well, a couple more seconds after I explain parabolas that open up and down. Okay, we got a bunch of similarities here. So here you have a parabola that opens up, which means if your parabola opens up, we use the first equation, right? But now the lattice rectum's different because now look where our focus is. Now it's going to say whatever your x value is, you're going to go right 2a and to the left 2a. That's what it is. So for this focus here, we would go left 2a, right 2a, and you would have your lattice rectum. And then your directrix is now a horizontal line. So it'd be y equals k minus a. Your focus is h comma k plus a, and your vertex is still known as hk. Kind of just like the circle. The circle gave us hk, and the parabola is going to give us hk. And the ellipse and the hyperbola, when we learn those, will also give us a vertex at hk, a vertex or a center at hk. All right. So that's if your parabola opens up. If your parabola opens down, well, again, guess what the big difference is? That 4a is negative. Okay. So these equations are here to let you know which one to use. All right. It just makes it a lot easier if you know what equation to use, how the parabola opens. And remember, placement of the focus when it's next to the vertex lets you know how the parabola is going to open. So look at the first picture. Vertex is here. Focus is there. We open up. Look at the second picture. Vertex is here. Focus is there. We open down. Crazy, right? And if you looked at the above pictures, it would be the same. Okay. So with that being said, I said we would compare the equations for a parabola that opens up and down to a parabola that opens left and right. Well, let's look at our equations. So for a parabola that opens up or down, we notice that, so just look at these parts. If it opens up or down, we have x minus h squared. So in this equation, x is the only squared variable. Y is not. Then look at the equations above at the top. If your parabola opens right or left, guess what variable is squared now? The y's are. So that's the big difference between parabolas that open right and left and parabolas that open down. Parabolas that open right and left have the y variable squared. So you have y minus k squared. I got scared for a second. I thought I wasn't recording. Okay, and then if your parabola opens up or down, then it's x minus h squared. So notice those differences. You're like, I don't know which one to use. Well, right or left, y squared. Up or down, x squared. All right, excellent. Let's keep going then. Let's get to some problems. Now, this is all the information we need for a parabola. Oh, and looky there. I had the equations for us above in the paper. Okay, so find the equation of a parabola. Find the equation of the parabola with the vertex at -2, 3 and the focus at 0, 3. Find the 2 points that define the lattice rectum and graph the equation. Okay, well, what we're going to need to find is how the parabola opens, and then we're going to need to find the value of A. If we know the way the parabola opens, this means we can find the equation, and if we know the value of A, that'll help us find the focus, the directrix, the lattice rectum, and finish the equation. So A is important, and direction is important. So the easiest way to go about these is just graph from the beginning. So our vertex is at -2, 3, and our focus is at 0, 3. So I'm going to scroll down and plot those. -2, 3 is my vertex. -2, 3, there's my vertex. And then 0, 3, right? 0, 3 is my focus. I'll zoom in more. There we go. There's my focus. Well, guess what, guys? We just found the value of A. Remember that A represents the distance from vertex to focus. So how many units away is the focus from the vertex? And that answer is 2 units. A is 2. Which means we can go ahead and find the directrix. So if the focus is to the right of the vertex, this means the directrix has to be to the left of the vertex, the same amount of units. So we're going to go 2 units to the left from the vertex and find the directrix. So 1, 2, right here is where our directrix will be, and it's going to be a vertical line. Now, how do we know it's going to be a vertical line? Well, first of all, one thing we must notice is that the focus is to the right of the vertex, which means this parabola is going open to the right, right? Our parabola is going to open to the right because of the focus placement, but we want to do it properly. I'm just labeling everything, right? And if our parabola opens to the right, well, this means that If we go up and look, if we open to the right, our directrix is going to be x equals. And remember, if x equals any number a, that is always a vertical line. So this means if I scroll down, I will now have a vertical line I can go down the whole graph, but we don't need to. I will now have a vertical line at x equals 1, 2, 3, 4, -4. That is my directrix. Okay, so we have a lot of pieces, and like I said, all we really need now is the direction that the parabola opens. The direction tells us what equation to use and the value of a. So let's write down all those important pieces. Yes, I know they wrote the vertex in the actual problem, but let's go ahead and just write it down again, because I just want to list all the important information. So, oops. Vertex is at -2, 3. Focus is at 0, 3. The value of A is 2. We just found the directrix. At x equals -4. And what we know is that this parabola can't write today, opens right. And if this parabola opens right, we have the equation y minus k squared equal to 4a times x minus h. So y minus k squared equal to 4a times x minus h, just like I have above. So I said we open to the right, which means we use that equation for a parabola that opens to the right, and we have found the vertex, we have found the focus, we have found the directrix. We didn't have to use those complicated formulas in the very first 3 columns. And then next, we will find the lattice rectum. Let's complete the equation of this parabola first, and then we'll find the lattice rectum. So let's plug in what we know. All right, so vertex is -2, 3, so we're gonna have y minus 3 squared, because that's the k value of the vertex, equal to 4 times a. Well, our a value was 2, so we're gonna get 8 times x, and if h is -2, then this is going to be x plus 2. And there it is, y minus 3 squared equal to 8 times x plus 2. Okay, and now let's find the points of the lattice rectum. Okay, so looking at above, if we're going to find the lattice rectum, let's just plug our a value into this formula. Y equals plus or minus 2a. So for the lattice, y equals plus or minus 2a. which means we'll get y equals plus or minus. If the value of a is 2, then we are going to go from our focus on the graph, we are going to go up 4 places and down 4 places. So let's go ahead and do that. So we haven't completely found the lattice, but what we just found here is how many units to go above the focus and below the focus. All right, let me erase this. So now, from the focus, I'm going to go up 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. And there it is. Those are the points of the lattice rectum. Let's write them down on the left side. I'm at 4, 5, 6, 7. So I have one at my pen does not want to write. 0. Sorry. Might have to change the pen out. Yep. One moment. Let me change this pen out. It's finally gone kaput. Let me clean it. Let's see. Oh, okay. I'm changing the header. It's that, or it's my computer screen. One moment. All right, let's see. Oh yeah, all right. New pinhead, perfect. 0, 7, and 0, -1. Those are the points of the lattice rectum, which means we are now ready to graph. So from the vertex up and to the right, and down and to the left. And that's it. Not bad. Anyway, vertex, focus, lattice rectum. Oh, and one more way to prove that this is the lattice rectum. Remember that the length of the lattice rectum is 4a, right? Is 4a, which means that would be 8 units in length because a is 2. So from the focus, you can count up 4, you can count down 4, and 4 plus 4 is 1 million. Just kidding, it's 8. So that would prove that the length, we found the correct points of our lattice rectum. All right. Yeehaw. All right. Again. All right. Find an equation of the parabola with focus at -4, 0, and directrix at x equals 4. So again, let's plot points and see what information we can come across. All right, focus is at -4. Right, -4 is 0, right? Yeah, -4 is 0. There is our focus. And our directrix, let's see, is at x equals 4. So 1, 2, 3, 4. All right, so this is where our directrix will be, and since it's giving us x equals 4, well, we know that is a vertical line already. So you can just draw a vertical line there. Okay, well, how do we find the vertex? Well, remember that the distance from the focus to the vertex is the same as the distance from the vertex to the directrix. So that means that the vertex has to lie exactly right in the middle of them both, right? Which means that has to be at 0, 0. So that should be our vertex. Which means, again, we have found the value of A. From vertex to directrix, we get 4. A is 4. Okay. Let's go write down our important information. Also, what we can gather from this is that look at the placement of the focus. The focus is to the left of the vertex, so which means we're opening left. Okay. So again, write everything down. Vertex is at 0, 0. And then focus, they give us the focus, which is at -4, 0. Directrix, which was given as well, is at x equals 4. The value of A, which is important, happened to be 4. And we know that we open left. So we will be at y minus k squared equal to -4a times x minus h, because we open left. Okay, plug in the information you know, and we'll have the equation of this parabola. Lucky for us, the vertex is at 0, 0. So we'll get y minus 0 squared equal to -4 times our a value, which is 4, times x minus 0. We should get y squared equal to -16x. Okay, and then let's find the points of the lattice again. And since this parabola opens to the left, we are going to still use that same formula, y equals plus or minus 2a. So this means that we'll plug in our value of a, which is 4, and we'll get that from the focus, we have to go up 8 units, down 8 units to get our length of 16. Right? So we're using that formula again, the plus or minus 2a, which means from the focus, go up 8 units, go down 8 units. So 1, 2, 6, 7, 8, and then 1, 2, 4, 5, 6, 7, 8. Those are the points of the lattice. Let's go ahead and write them down on the left side. -4, 8, -4, -8. Okay, I think we have everything we need, so go ahead and graph it. This is a big parabola. Okay, and there you go. So this problem was different because we had to find the vertex. So if you're given the focus and the directrix, just know that the vertex is right between them. Okay, awesome. Okay. Given y squared minus 4y plus 4x plus 4 equal to 0, find the vertex, focus, directrix, we'll find the lattice rectum, all that good stuff. Okay, so now this equation is actually given to us in general form. Just like circles, it was everything foiled out and moved to one side. So this means we are going to have to put everything together, move the constants over, complete the square, and figure out, do we have a parabola that opens right, left, up, or down? Okay. So let's find out. Okay. So we have to look at how to rearrange this, and one giveaway of what variable to keep on what side is look for which variable is squared. So looking at our equation, it looks like the only variable that's squared is our y squared. So this means that we're going to keep all the y's on one side and move everything over to the other side. And the reason we do that is that's just how the equations work. Oops, why'd that go to the top? Sorry. Because again, look at the equations. You have y squared on the left side for the first two equations and x on the other side. And the last two equations, you have x squared on one side and y on the other side. So it makes sense when you're setting your equations up to complete the square, what variables to keep on what side. All right. So with that being said, let's go ahead and rewrite this. We will keep the y's on the left side. So y squared minus 4y, and move everything else over to the right side. Negative 4x minus 4. Okay. So now, what we're going to do next is complete the square on the left side, because we have to make the left side a perfect square to make the equation of a parabola. What? Right? Again, we completed the square to make a circle. We're now going to complete the square to make a parabola. So we're going to say CTS, and of course, when you complete the square, we take half of the middle term's coefficient and square it. So negative 2 squared and 4. And then again, what do we do with that number? We add it to both sides. Y squared minus 4y plus the 4 from completing the square equal to negative 4x minus 4 plus the 4 from completing the square. All right. And now remember that after you complete the square, the left side polynomial is always factorable because it becomes a perfect square trinomial. So we factor this, And we are left with y minus 2 times y minus 2 equal to, clean up the right side, your 4's will cancel, negative 4x. Okay, and again, once again, there's that trick, like how did you know what numbers to put in your parentheses? And remember, if you're completing the square, it's the number that you squared. So I squared negative 2, that number went in there, and that number went in there. Much fun, right? Totes fun. And then you'll get y minus 2 squared equal to negative 4x. All right, we have our equation, but now let's compare it to the formulas above and determine which way it opens. And also we're gonna have to grab more information from this equation. So y minus 2 squared, this means that we have a y squared on the left side. So it could be either of these two formulas, right? But then we look at the positive and negatives. Look what we have here, a negative 4x. Well, the first equation for a, or whatever's on the right side, is positive. The second equation, no matter what's on the right side, it's going to be negative. So this means that since this equation matches up to the second equation in our equations chart, this means our parabola will open left. Okay, so now, with that being said, if we open left, there's one thing we can find from this, and that's going to be the vertex. That's going to be the vertex. Okay, so if we look at our equation, the vertex is going to be 0, positive 2, right? 0, positive 2. And the reason it's 0 is because we can rewrite this part as negative 4 times x minus 0, right? And we get our positive 2 because this is y minus k squared. So that's where we get our vertex from. 0, 2. All right, we have our vertex, but now we're missing other components. We need to find the focus and the directrix, which means we need one more piece of information. We need to know the value of A. If we know the value of A, this means that we can find the focus and we can find the directrix. Remember, because A is the distance from vertex to focus and also the distance from vertex to directrix. Okay, so in order to find A, because we have it already, we just don't know what it is, we look at that second equation, and in order to find A, we take this negative 4a and we set it equal to the number that's in front of that x, negative 4. So we set negative 4a equal to negative 4, and we solve for a. That's it. Now you don't have to do this. Looking at it, you can guess what a is. Right now, I can tell you that a is 1. But it's always good to set up some type of equation to help you find a. So let's do that. So we'll say a, and you take that negative 4a, and you set it equal to that negative 4, divide by negative 4, and a is 1. Okay. So let's piece it together. We can start graphing already. We know that we're going to open to the left, which means once we plot the vertex, the focus is going to be to the left of the vertex. Okay. So let's do that. All right, focus is at, vertex is at 0, 2. So 0, 2, there's my vertex. And since we open to the left, and my value of A is 1, if we go left 1, there it is, there's my focus. Let's go ahead and write that down on the left side. Is at negative 1, not 1, negative 1, 2. And then from the vertex, if we go to the right one, you have the directrix. And that's at x equals 1. So okay, we have the equation, we have the vertex, we have the focus, the directrix. All we need is the lattice. Okay, all we need is the lattice, and we will get that formula again, y equals plus or minus 2a. Since our a value is 1, we get y equals plus or minus 2. So this means from the focus, we will go up 2, down 2. 1, 2, 1, 2. And there's our lattice rectum. So let's put those points down. We will be at negative 1 and 4 and negative 1, 0. Okay. Now let's go ahead and complete our parabola, and we're done. There it is. Perfect. Okay, awesome. I'm sorry we only dealt with parabolas that open left or right. But it's going to be the same situation if you're dealing with a parabola that opens up or down. Know your pieces, know your value of A, know how to work your equations, and you will be fine. Okay, last problem. All right, we have something called a paraboloid revolution, a surface formed by rotating a parabola about its axis of symmetry. If a light is placed at the focus of the parabola, all the rays emanating from the light will reflect off the mirror in lines parallel to the axis of symmetry. This principle is used in the design of searchlights, flashlights, automobile headlights, and other devices. So you're just looking for lights or maybe signals that come in, bounce off, and then reflect back out. That's what our paraboloid revolution. Conversely, suppose that the rays of light emanate from a distant source so that they are essentially parallel. When these rays strike the surface of the parabolic mirror, whose axis of symmetry is parallel to these rays, they are reflected to a single point at the focus. I think that's just what I said, but simpler, right? This principle is used in the design of some solar energy devices, satellite dishes, and telescopes. All right, so basically, how can we position a satellite dish to record better alien signals? There you go. All right. Or how do we get free NFL football on Sunday? However you want to go about it, right? All right. A satellite dish is shaped like a paraboloid revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point where the receiver is located. If the dish is 8 feet across at its opening and 3 feet deep at its center, at what position should the receiver be placed? That is, where is the focus? So our job is to find the focus, because we want to know where the signal's going to strike this at. What height should we put the focus? Okay, so what's given, and I'm going to draw a graph here. Is that our satellite dish is 8 feet across. So we have to figure a way how to put this on a coordinate plane. So if I put 0 here, right, or 0 there, and if our dish is 8 feet across at its opening, this means from 0, we are going to go right 4 units, or right 4 feet, and left 4 feet. So we're going to go 1, 2, 3, 4, and 1, 2, 3, 4. This represents my 8 feet. Okay, but then also it says that the dish is 3 feet deep. So this means that from the base, our dish is 3 feet deep. So we're going to go up 1, 2, 3. So that will represent the depth of our satellite dish. Okay. So then to complete this, we know that if we go out to the right 4 feet and up 3, we'll have one end of the dish. So I go right 4, up 3. There's one end of the dish. So from the center, or the vertex, there's one part of the dish. This is at 4, 3. And then, to make the rest of the satellite dish, we go left 4 and up 3. And now we have another point. Negative 4, 3. And this would be our satellite dish, right? Okay, we don't need that part though. Okay, so what we're trying to figure out is where do we put the focus? And now what we have to know is that, well, in order to find the focus, we need to find the value of A, because the way we place this satellite dish is we are saying that the vertex is at the origin, right? The vertex is at 0, 0, okay? The vertex is at 0, 0. All right. That's the vertex. Well, what we must figure out here is that we now have a parabola that opens up, which means that if we look at our formulas, a parabola that opens up will use this formula. Hey, we have a problem that has a parabola that opens up. Great, good times, which means since in our application the parabola opens up, this is the formula, the equation we're going to use. So let's go ahead and write that down on the next page. So this opens up, meaning we'll have the formula x minus h squared equal to 4a times y minus k. Okay, and let's plug in what we know. We know that our vertex is at 0, 0. So if I plug in 0, 0, you'll have x minus 0 squared equal to 4a times y minus 0. What we end up with is x squared equal to 4a A, Y. So this equation represents our satellite dish. It represents a parabola that opens up. But we still need to find where to place the focus. So again, in order to find the placement of the focus, we need to find the value of A. Well, how do we find the value of A? Are we given another piece of information to help us find this value of A? And I guess what I'm asking is, are we given an X value and are we given a Y value to plug in and help us solve for A? And that answer is yes. We have actually two X and Y values. So in order to solve for A, we can plug in 4, 3, or we can plug in negative 4, 3. It does not matter which one you use. So let's just say, let's choose 4, 3. So I'll have 4 squared equal to 4A times 3. I plug in 4 for X, 3 for Y. We get 16 equals 12A. Divide by 12. And you'll get 16 over 12, which reduces to 4/3 equal to A. And since we are talking about distance here, we want to know the exact place to put it. So in order to receive signals best, the receiver or the focus should be placed at 1.33 feet. Okay, which means if I were to plot that on my graph, there's 1, so right around there would be the focus. Or in this case, the receiver. Okay. And that's it. So that's how you find other pieces of information again. So we were given the vertex and we were given a point on the graph. If we're given the vertex and a random point on the graph, we can find the value of A, which can help us find the focus, and it could also help us find the directrix if we were asked for the directrix. And as well, it can help us find the lattice. All right, guys. That is parabolas. So just know what equation to use, know the direction. So if you know the direction, you know which equation to use, and if you know the value of A, you're all set. You have all the pieces you need. If it's like the very last one, if they give you the vertex, we can find the equation. We can, if they give us a vertex and a point, we can find what equation to use, how it opens, which means it can lead to help us finding A, which can lead to helping finding focus, directrix, and lattice. But that is it. That is parabolas. All right. Till next time.